Okay, so we're going to start today's session. This is focusing on the use of FME with the Google platform. My name's David Eagle, Managing Consultant at OneSpatial, and just a little bit about some of what we're going to cover today. Well, perhaps one thing that's not going to need too much introduction is actually what Google is and what it's all about. So I'll keep that nice and brief. Where we're going to focus our attention is around the individual formats that FME can work with around Google, and that includes some of the more common and popular ones like working with KML or Keyhole Markup Language, adjusting data and writing data in and out of Google Sheets, working with Google Maps Engine and what the story is with the future for Google Maps Engine, focusing on communication via FME using Gmail, and also looking at some of the capabilities around some of the Google Web Services and live data stream approaches that we can incorporate with the Google platform and use and make available through FME. OneSpatial, we've been around for a good while now, 45 years or thereabouts, born out of Cambridge University, and we've got a number of offices globally. We're headquartered in Cambridge, and my colleague Hayley, who's also on this call, is based over in Cambridge at the moment, and she is fielding some of your questions. So do feel free to submit any questions you've got throughout the session through the chat window. We will pick those up with you either immediately after the session. I'll talk them through, or we'll drop you an email with some details around your specific request. We work with a number of different technology partners, and the focus for today is around working with Safe Software. I specialise in the FME product set, and I am a FME certified professional and FME certified trainer. We have a number of consultants globally who all have different technology capabilities, either across a number of different providers, whether they're proprietary or open source technology stacks, or individuals who focus specifically on one or two bits of technology that we work with. We're reasonably agnostic when it comes to software technology. We like to make sure that we're providing the best solution to our customers. So we have a broad range of tools that we can access to help you out. Safe Software, their 20th anniversary year last year. They work with all of the vendors that you can see logos for on the screen and many more besides. Whether those organisations, as I've mentioned, are proprietary organisations or whether it's the open source technology, whether it's CAD or GIS or CRMs that you're interested in, or perhaps it's just tabular data stored in the cloud. All of those environments are accessible into and out of FME. You can move data between them. FME and Safe Software as the company are all about moving data between environments and manipulating, transforming and restructuring that content. As I've said, the focus is around Google today. Safe Software make three products: FME Desktop, FME Server and FME Cloud. I'm not really going to be spending much time focusing on the capabilities of those individual tools and what they are from the ground up today. That has been covered adequately in earlier webinars in this series. So do go and take a look at youtube.com/OneSpatial group, or the FME channel also on YouTube. Directly from Safe Software, which is where you can see a number of these sessions and potentially new sessions coming up around all of those tools that you can sign into and take a look at what has been said in the past and sign up for new sessions in the future. We have ourselves as OneSpatial been a reseller for FME for a number of years now. We support all of the FME products, both on the desktop, server and cloud, and we have certified staff around the world to help you. The result of having this dedicated capability is that we can help you choose FME as the right tool for whatever you're looking to do, making sure that it's the best fit. So we'll help you do product evaluation so that you are effective in evaluating the tool and making sure it is the most appropriate tool for the job. We provide technology consultancy around FME, helping you to build FME workspaces and processes and integrate those with your environment. And we'll provide dedicated tech support and also training services for you and colleagues if you need it. What's Google then? Well, does it really need introduction? It's so involved in modern life, so much so that people refer to Googling something rather than searching for something these days. It all began with search. That's where the focus was originally. And what Google does now is very, very broad ranging. If you have a smartphone, if it's not an Apple device, it's likely to be an Android device. The operating system that Google builds to support tablets and Chromebooks and all sorts of different touchscreen devices. They are looking into self-driving cars. They do voice recognition around Google search. They manage and maintain YouTube. Google Maps are very commonly used for routing you from one place to another, and there's so much more that they do. It's quite amazing to think that Google really only have been around since 1998. They very much now are part of daily life. The interesting thing for us in this session, though, is how FME can interact with Google. And initially that support is around formats. And if you have an FME Professional Edition license or greater, then you can read and write all of these formats. It effectively, FME gives you access to 10 different formats that Google produce and maintain. Let's just walk our way through some of those, and you can too if you go to safe.com/formats. On that site you'll be able to do a search for the different formats that are available via Google. Just put the search term in just at the top here. It'll shorten the list for you, and then you'll get to see some of the formats that are available. Google BigQuery is one of the newest formats that Google are putting out there. It's a managed NoSQL database, and Safe have put it up as a technology preview, which means that in Safe's terms it's not ready yet, which suggests that Google haven't quite finished prepping that environment. So that's something to be aware of. If you ever see tech preview in brackets after a format name in FME, it means it's not quite fully fledged, effectively a beta if you like. Google Cloud SQL is MySQL in Google's cloud. So in the case of reading and writing that data using FME, you use the MariaDB reader and writer. That's the open source reader and writer for MySQL databases. A few changes happened a few years ago, which is why MariaDB exists. Do a Google search and find out more about MariaDB and that open source project. You can also see that there are formats called Google Fusion tables. Those also offer non-spatial and spatial equivalents. That is a way of storing large tabular data in the cloud. Google Fusion tables, you can create those. Generally you would use a Google Fusion table if your data was much more considerable than perhaps you wanted to manage in a spreadsheet. And you don't necessarily need spreadsheet-like functionality. So a Google Fusion table may be more appropriate for you in that scenario. When it comes to KML, a lot of people in the spatial arena at least have heard of KML, and quite a few people know about it in lots of other walks of life, but perhaps don't know it as the KML acronym. Keyhole Markup Language, or KML, is also available as a compressed format, KMZ. It's very commonly downloaded as a file on the web in KMZ format. Which contains all of the little components that might be interesting for you to look at, and it's often used as a way of sharing walking routes or cycling routes with individuals in clubs and that sort of thing. So we'll look at that in a bit more detail. And then there's Google Maps Engine, and I'm going to say very little about GME. Google Maps Engine, it was a project that got a lot of people excited to begin with around the ability to work with mapping in the cloud. Sadly, Google have deprecated that project though, and official support ends for it in January next year. So that's a project that started very quickly and was over very quickly as well. FME does support it at the moment and supported it from its inception, but it will be removed as a format capability very soon. Google Spreadsheets as another format. This is a format that SAFE have supported for a good while now as Google Spreadsheets. It's now called Sheets, and if you have FME 2015.1, so a point release, then the Google Sheets format came with that edition of that version of FME. So a little bit more on that shortly. And then finally there's the WebP format. That's actually a raster format, and Google developed it specifically for storing images on the web. It supports a number of different compression types, and again that format is supported to both read and write in the FME product, Professional Edition and above. So that's a little bit about some of the formats. Let's focus in on a few of the technologies. Google Earth is probably one of the most well known. It's a very established format, that's KML, and Google Earth's history was that it was a product prior to being Google Earth. It was called Earth Viewer 3D, and it was created by a company called Keyhole Inc. And Google, as with so many companies, Google acquired them, and it became part of the typical Google stack in 2004. And one of the most interesting changes in recent years has happened this year, and that's that Google Earth Pro is now free. So if you've got the standard Google Earth downloaded and installed, go and download the Pro version, the Pro edition. Just go and search for Google Earth Pro or Google Earth Professional, and you'll find it to download it. And you do have to register to use this, but actually if you use your email address and GEP free when you sign in, then you don't need to pay for it. So it's a $400 saving effectively, and it allows you to do some GIS-like functionality within Google Earth natively. So it's a worthwhile download for a couple of minutes of your time if you are a Google Earth user and you didn't realize that. So working with KML or using FME, there are a number of dedicated transformation possibilities. You can consume data from all of the formats that FME supports and write that out into, in this case, KML if you wish. It supports compression. You just change the file extension. The one interesting thing about the KML format is that it does only support one coordinate system. So on our support desk we occasionally see questions from individuals saying, I've tried to write to data to KML, but as soon as I press run on the workspace, it very quickly fails. And that is often a problem with data that you're processing through FME and writing to KML if your input data doesn't know where in the world it is. Google Earth, one of its requirements is that the KML format receives data that has a projection defined. So if you're reading and creating data from CSV or Excel, making that as points on a map in Google Earth, then you'll need to use a coordinate system setter to define the coordinate system before it enters the KML format. One of the interesting things though is that you don't need to reproject it. Whatever coordinate system you pass into Google Earth, the writer actually carries out the reprojection, because whilst it must have a coordinate system, it only supports one, and that's lat long. It supports raster and vector data, 2D and 3D data. It supports animations that are time-based, and you'll see a little bit of that at the moment. And it also supports fly-throughs, so we can play around with lots of different capabilities in this very elaborate format. So just to give you a few examples, we'll pop open a couple of processes that show you ways of reading data and writing into the Keyhole markup language format. Let's go and pop open a process that reads land registry parcel boundaries, and this is just going to drag it onto screen now. There we go. So if I just zoom in a little bit, you'll be able to see that a little bit better. It's a very simple process. Effectively, this has an Inspire GML reader on input, and it's actually pulling data from the data.gov.uk site. We're going to get the City of London Inspire index polygons that are published by the Land Registry. And you can actually notice that we're reading that from a URL. If I just pop this open in a bit more detail, what we'll do is just go and show you the data.gov site. So data.gov.uk is over here, and if I do a search in Google for Inspire index polygons, we can have a look at what's available via data.gov. And here you can see that for every major conurbation in the UK, you can download all of the registered polygons or registered plots of land for the country. So, for example, if I go to South Wales, in here we can see there's a URL that allows me to download the zip file. If I click it, we can download it directly. We'll just tuck that out of the way for the time being. So FME in this case is reading the City of London directly from the web, so if the content changes then we will always have the latest data. It's also reading the zip file, so inside the zip file is the GML. It's extracting that automatically. We're throwing away any attributes we don't need. We're exploding the geometry because what we've actually got is a land parcel with a bounding box around it, and we don't want to keep the bounding box, so we throw that away. So of the pieces, if the geometry name is not equal to bounded by, then we're not interested in it. Anything that passes that test, we find out how big it is and define it as an area in square meters. And then we use a couple of dedicated transformers around the KML format. The KML styler allows me to set the fill and the boundary color, and also the fact that I'll be able to see through it. We've got an opacity set there as 40%. And the KML property setter allows me to put one of the attributes in as the KML name, and also define how the KML interacts with 3D features in Google Earth. In this case, we're going to clamp those vector features to the ground. So if I run this process, zoom extents a little bit, we can see this piping the data through. So this is reading directly from the web, so you can see that the dynamic feature count shows all the features flooding in from the internet through the process, through each transformer, and writing out to the target. If I right click and open the containing folder and drag that in, we can see that now that process is finished, we have a KMZ file. If I wanted a raw KML file, in order to swap that over without having compression, I literally need to just change the Z to an L on the file extensions. So it's that simple. So if we go and have a look at the output, bearing in mind this is read data directly from the web, double clicking the file initiates Google Earth to open. It zooms into the target location of the source data, and we're into the City of London here, and we'll let that render on screen. And there's the River Thames running down the south of this section here. If I zoom in a little bit, you can see that we defined red polygons, and I'll just go to the periphery of the City of London so that you can see the difference. I'll just let that render, and you can see that if I click one of the polygons, we have the cadastral reference stored as a name here, which is what we did in the KML property setter transformer. We have a timestamp, which is when there was a most recent change in that property and in that plot of land, and we also have a physical area in square meters. You can also see that I've written a one spatial logo, an FME logo, into the KML. We can toggle that on and off if we wish. And if you happen to know a reference number that you wanted to navigate by, we could just go straight to it, double click it, and it will take us there. So just a little bit of functionality within the KML format. We're effectively consuming open data from this process directly from the data.gov.site and writing that out into KML just for further inspection. What else do we have? Well, we've got a couple of other scenarios. If we have a look at another process, which I'm just going to launch. A few years ago, I was lucky enough to go on a hot air balloon ride, and I took a smartphone with me and tracked the journey whilst I was in the balloon, and came back and built a process immediately after the flight in order to identify the route that I'd taken. It was a fun exercise. It gave me a record of the journey, and it's not necessarily something that you would use FME for all the time, but it's a way of learning new capabilities when you work and use FME for something that's important to you as an individual. Many of you out there will be cyclists or hikers, and this same technology, the same capability is useful here. I actually used at the time an iPhone app from a site called trailguru.com. That website no longer exists, and that service doesn't exist anymore, but there are plenty more. That site in particular gave me the ability to upload the route and download a GPX file. The GPX file option, as you can see just here, if I bring this in, there's the GPX file that allows me to build this process. And what I'm doing is I'm reading that GPS data in. The GPX file contains a couple of layers. One is a track, which is a linear feature that traces the route from A to B, and there are also track points, and those track points are satellite pings along the way to give me a position. What I'm doing here is that with my particular phone, it didn't have a very good GPS, so every now and again the GPS connection dropped out, which meant that the point plummeted effectively down to 0. So in data terms, that would make it look like the balloon was landing very frequently. So what I've done is I've used a transformer called a neighbor finder to take all my points and effectively take the nearest point that has a good height, and steal that height value and glue it on to the feature that's passing through. So it is a crude bit of interpolation to make sure that I have height values that are appropriate all the way through my workflow. And then all I'm doing in a very long-winded way in order to demonstrate to you what's actually happening, but you can see here there's a transformer called an attribute range filter. The range filter allows me to define ranges, which then defines a different port per transformer. So if my balloon height was between 0 and 200 meters, then I'm going to style my balloon, and that's a balloon.gif. So I have a little GIF balloon, which I'll just show you. I'll pop that open on screen here. So if I just edit that, there you go. So very simple little balloon. I'm taking that balloon image and I'm going to apply a color to it. So it's stored in the same directory as the workspace, so that's why I can reference it, and I can color it here. And each of those KML styler transformers changes the color so it's slightly darker as we get higher up. Here's a sort of a reddy brown color at the highest altitude. Rename a couple of the attributes, and then I'm going to use a substring extractor to extract from the creation time attribute some of the time values. So in this case I'm going to grab the year, the month, the day, the timestamp, and I can use the property setter to define some of these values. So I have a description balloon in the KML pop-out balloon when I select one of the balloons on the map, and into there I've used the option here, which is effectively an embedded string concatenator, and I'm taking a constant value which is a date, and I'm setting that to the day and a forward slash and the month and a forward slash and a year and a time, and putting the value in here from an attribute. So you literally drag and drop the values that you want to use across into there, and you build up your syntax along the way. So I don't want to save those changes. So I've got a concatenated string defined as the summary and the content for the balloon and the navigation tree, and my timestamp is going in as the name. Again, in this case I am setting the vector data to be relative to the ground rather than clamped to the ground, because I want my balloons to be a bit more interesting than just sitting on the Earth's surface. There is also a relatively new, in the last few years, a KML time setter. Now this functionality was possible in FME previously, but you had to set time values manually, setting the FME attributes. Now the time setter exists, and all I'm going to do is define a timestamp value, which is my creation time. Effectively, the GPS ping time is going to be put into this timestamp field. And that enables, just by doing that one thing, it enables time slice functionality in Google Earth. I'm then taking my altitude that was stored in the GPX and forcing that onto the third dimension. So until this point in the workflow, I had a 2D data set. I have taken elevation and created a Z value here. And then taken the elevation and, just for the sake of this exercise, concatenated an M on there to represent meters to make it look a bit nicer in the workflow. So important parts here are some interpolation, some styling, and the definition of the KML function over on this section, just over on the right. And if we go up to the top, we're taking the line. This is effectively like defining a flight path or flyby of my hot air balloon. So if you imagine a helicopter following the hot air balloon, apart from making the occupants of the balloon reasonably nervous, what that would actually be doing is filming the balloon in the flight. In this case, I'm generalizing the linear route and tidying it up a little bit, and then just dropping it straight into a KML tour builder transformer. Here I'm defining that the tour should be 120 seconds long, and I want it to be a transition smooth, and it's in the perspective of the third person, and it's going to be 2,000 meters away from the balloon. So we'll see that in a moment. You have to a little bit of trial and error with some of those settings. I'm writing that out also to the KMZ file that we're producing. So if I run this process, it reads the GPX format directly. It creates the tour, applies the style, and if we go on and have a look at the balloon flight, so I just double click the KML file, there's the KMZ that's just been created. There's the timestamp to prove it's true. So we bring in Google Earth, and you can see immediately it launches the time capability in the top left hand side of the screen. That's this little area here. I've written an elevation profile just as a small raster, so rather than a logo, this is an elevation profile of the flight, and here we can see the individual balloons. So first of all, if I just zoom in, you can see that the ground is moving at a different rate to the balloons when I zoom in, and that's because each of these is an elevated balloon. Here's some of the attributes that I've constructed. You can see the timestamp, and that's the concatenated string that I built in that workflow. There's the elevation at 952 m for meters, which I also concatenated onto that value. If I tilt my view, so press shift in Google Earth, whilst tilting, we can see that we can see the elevated balloons and their individual height, and I can pan around a little bit. And if I go into the navigation window over on the left, if I double click on the tour, it starts the tour, and down in the left hand side is the control for that. Now this may or may not display in too much detail over the projection on your screens. It might be a little bit blocky. I can assure you that when you do it yourselves, it will be a very smooth transition of a vehicle effectively tracking along that balloon route in this case. I'm just going to pause that process because what I'm also going to do is just go back north and just zoom back up here, because what I want to show you is the time slice functionality. If I take the time slider and push that all the way to the left, I can then, and I took off from down here, I can then slide it along, and you see that slowly balloons are starting to appear. And if I zoom in a little bit more on the individual area, you'll see that at any point, in this case 9:07 AM, and move my way to 9:10, and it's starting, the balloons are starting to go off screen. and the altitude is starting to pick up. So you can do this quite nicely with raster data as well. So if you want to show raster photos over time, you can do that. And there's also general functionality in FME to allow you to look at things like historic imagery. So you can roll back and forwards between historic imagery in here if you wish. So you can see different imagery that was available in different years using the little imagery slider. And you can also look at sunlight. So we can have the sun and the time of the sunrise and sunset and what shadowing is likely to happen. And you can play around with a little bit of that functionality yourself. So there's quite a little bit of capability that's offered just by writing a process through this FME product and writing data out to KML. So some of the other examples we'll take a look at, moving away from Google Earth now and focusing on more data that perhaps a wider population of people care about, and that's spreadsheets. So we can see that we have access to the Google Sheets format. As I mentioned at the start of this session, it used to be called Google Spreadsheets, but Google adapted the API and also changed the product name, and as a result SAFE had to migrate their reader and writer functionality in FME, and that meant that that new format came along in FME 2015, the 0.1 release. So if you haven't downloaded that yet, it was made available about a month ago. It's available on safe.com/downloads. If you have an earlier version of FME, then you will only have the Google Spreadsheets reader and writer, and that won't work with the new API for Google Sheets, so you'll need the latest version. The interesting and useful thing is that SAFE haven't made you wait 12 months to get access to that new reader and writer. It's available in a point release that you can use with your existing license straight away. Bear in mind, point releases are separate installations, so you could install FME 2015.1 on the same machine as an old FME 2014 was installed and use the same license, and that's legitimate to do with your particular license. Google Sheets really offers an alternative to something like Microsoft Excel or some of the open source technologies like OpenOffice. It does rely on a web connection to synchronize the sheet, but you can get offline access to the sheet through your Google Drive setup. So if you have Google Drive installed and you have a local instance of the sheet itself, then you'll be able to open that up without having to worry about having an internet connection. Writing to Google Sheets, really it is just another format. You need to give FME access to effectively be authorized against your Google Drive, and I'll just quickly show you how that works. If I wanted to very quickly just create a Google Sheet, I'll just pop open Workbench and pop in here a creator. I'm not going to run this, I'm just going to show you the quick process. Add a creator and just zoom in a little bit, and I'm going to add a writer and search for the Google format. So if I look for Google Sheets, I don't have a data set that I can click into, so I'm forced to push the parameters button, and you can see here that I need to get a refresh token. In this case, I need to go and sign into an account. I have an account that I use. So I just need to punch it in without typos. And sign in. And there we go. And that authenticates FME against the Gmail account, well, effectively the Google Drive account and Google Sheets. So if I accept that, it applies a token, and then I can go and define what spreadsheet I want to write into. Okay, so it's simple as that. You need a Google account, of course, in order to get that far. So when you have a process defined, and I've got one that I've pre-configured just for speed, so if I just pop that open, this process is going to read some data. Again, I'm reading data that is open data from the web. This time I'm downloading planning applications. So if we zoom in a little bit of a advert, I suppose, or a bit of a information about some of the local authorities in the UK that are publishing open data. Nottingham is at the forefront of this through Open Data Nottingham. A lot of the data that is published via Open Data Nottingham is actually put there and made available using scheduled FME processes, and that includes the planning application data that I'm looking to download. So if I search for planning application on this site, you can see that there are some planning applications from Nottingham City Council, and this CSV file turns up in this location for download automatically, and it happens overnight. So an FME process runs overnight and puts that CSV file in a web accessible directory for people to download the latest planning applications. What I'm actually going to do is take the URL to that file, and you can see that I have a CSV reader in my process, and I'm pulling the data in from CSV. You see the planning application file there, reading it in, and all I'm doing is testing that the case date contains 2015, so I'm only interested in planning applications that have been submitted in 2015, and I'm only interested in full planning applications. So this is a test that says it's in 2015 and it's a full planning application. I'm not interested in street signage, that kind of application. I'm only interested in planning applications for buildings. So I then have my writer defined, and if we go and have a look at the Google Sheets writer, there's a few things set up in here. There's my token for my account. I'm going to write into a new spreadsheet called Nottingham or Not Planning Apps, and I'm going to put 5,000 cells in there per request. Over on the actual writer feature type, we're putting in a whole bunch of attributes, and we can see those in here. There's my attributes that I'm going to write into the spreadsheet, and importantly, I'm getting the extract date. So as this happens every night, the extract date will bear the date that the data was extracted to that CSV, and I will create a sheet with effectively a tab in it that is based on the extract date. So if I go and find my Google account, I've already pre-logged in. If I go into my little apps up here, I can go to Google Sheets, let that refresh, and you can see that at the moment there are no spreadsheets in there. So I'm going to just nudge my screen around a little bit so you can see what's going on. Make that a little bit bigger. And just going to zoom extents and run this process. And now what should happen is that it connects directly to Open Data Nottingham, grabs the data directly from Open Data Nottingham on a URL and reads the CSV and consumes the data. If I just click over into Google Sheets and F5, you'll see that the planning application Nottingham spreadsheet has appeared, and it's starting to write data. It's finished consuming it, it's now just pushing it up to the cloud. You can see that all those features are being pushed into the Google Sheets writer. Now I can at any point click into the spreadsheet, even when it's being written to, and it should refresh and show us the content. And we'll just let that get on with it. You'll see that the worksheet has the name of the date, the extract date that we defined. So if I ran this on multiple days, then I would get multiple sheets in this same Google Sheet. So you can see all the content. If it's a URL in the CSV, then it automatically embeds it as a URL. You can see all the data in there. And you can see that based on my filtering system, I only have full planning applications being recorded in here. And hopefully they are only in 2015. And that over time will refresh to include all of the cells that are in there. So it's as simple as that. You can move data around into Google Sheets, and you can read it back from Google Sheets, and then you can make this spreadsheet available to colleagues or friends who can collaborate with you, make changes to it, and you'll see that real time. An advantage of Google Sheets over some other sort of client-based spreadsheeting tools. They're different applications, depends on how you want to use them. And there we go, it's written all the cells into that sheet now. So let's just go back to the main Sheets interface there and just minimize that and minimize that. Google Maps Engine, I said at the start it would be very quick. I'm not going to dwell on it. There have been plenty of webinars done already on Google Maps Engine's capabilities. Do go and take a look at One Spatial Group and also FME channel on YouTube. SAFE have done a number of sessions dedicated to Google Maps Engine, and what I would suggest is that now that that project is deprecated, I believe you can't actually create a new Google Maps Engine account, so it's only any good to you if you already had one. You will be able to continue to use it in FME until such time that the project is fully terminated. At the moment that is pegged for January 29th, 2016. So if you based some of your workflows on Google Maps Engine, then the next step is to work out what your options are. Two useful examples of cloud-based mapping systems are ArcGIS Online and also CartoDB. And there are a couple of very useful sessions that SAFE have done, and I'll just populate or show you one of those quickly.
Hi, I'm Tiana from Safe Software, and I'm going to show you how to migrate Google Maps Engine data to ArcGIS Online using FME.
And there we go. So there are a couple of sessions that Tiana has done from Safe. She's done those focusing around consuming data directly from GME and writing out to another online mapping system, in this case AGOL or ArcGIS Online. Email, using that with FME is an interesting capability, and it's done in a number of ways. Email is a very common protocol. Most people manage their email in one way or another, and some, in fact, many millions of people globally use Gmail. It is a very quick and easy way of getting email set up. It's just one of many cloud-based email solutions that are out there. So I'm not promoting this in any way, but obviously this is a Google focused session, so obviously their email capability is Gmail. As I say, it's easy to set up a Gmail account, which means that you can create an account that you can run sessions from, and the two main approaches around emailing with FME are where you do something in FME and then FME sends an email. Now you can do that during a process, and that would be triggered by a feature sent to a transformer. So perhaps you've got a process where a feature that you weren't expecting in your process is tripped over during the session. You can fail that, send it to a transformer and email an individual or many individuals or maybe an administrator to tell them that that feature appeared in the process. So perhaps it's a geometry type that you weren't expecting, or somebody has made a request for some data that you don't yet supply. The other scenario would be after a process is run. So that's where an FME workspace runs to completion, and then a shutdown script triggers that email to be sent. The last scenario is where you actually send an email to FME and it then does something. And that's really the capability that's supported by the FME server and FME cloud product, and I'll touch on that in a moment. So let's take a look at the first option here, which is a process of emailing during a workflow. So I'll just clean up my screen a little bit, and I'm going to bring back into view the workflow that does that. So this is a rather contrived example, but hopefully you'll get the idea. Effectively, I have a little workspace here that gives me a JSON feed. So it's a JSON feed of an electric car track. And if I go and open up the containing folder to the JSON file, and I'll open that up in Notepad++, and bring that into view, you can see that I have a little bit of JSON data, and it includes information about the type of vehicle, the battery range, the vehicle ID, the battery current, charge power, importantly a longitude and latitude, and there's an important attribute in here as well, which is the speed of the vehicle. Each of those is a ping from the vehicle, and you can see a little collection of nested tags that are details about that location. What I'm doing is consuming that, and then I'm testing it to see if the speed of the vehicle is over 14 miles per hour. So if I lent my Tesla to my daughter, which is a bit of a daft example because my daughter's under 2 and I don't have a Tesla, but if those things were true and I didn't want her to go over 40 miles an hour, then effectively I would get those features that would fail, and I would receive an email. So let's go and see if this works. If I go on over to my Google account, and I'm going to go and pop open Gmail, and hope that in the meantime no one sent me a marketing email to buy something in here. So there we go. And if I run this, every feature should pass through. Those that are have a speed that is greater than 40 miles an hour should trigger an email to be sent. So you can see that I have an email arrived over here, and there's one email per feature in this case. So if I click on the first one, it says that my daughter is now exceeding the speed limit that I set for her, and she's currently traveling at 41 miles an hour. If I dive over to the other one here, still doing 41 and accelerated up to 42. So you can see that what I've actually done in this process, if I click into it, is I've defined a little bit of detail that is the email message, and you can see that I've inserted a value that comes from an attribute that's stored in the JSON. This is you'll notice this is a custom transformer. It's a green transformer. It's a little bit different to the normal ones that you get. It's available on the FME store. It's called the Python emailer, written by one of the developers at Safe. You can download it directly from the FME store, and we can just dive over to that location here if you wish, so you can download it from here. If I just go to the home location of the FME store, it shows you that you can get transformers, formats and templates written by people in the FME community. And the alternative is that you can type the transformer name and download it directly within the Workbench application, assuming FME can see the internet. So you might need proxy settings set up there. What else have we got? Well, we can use a shutdown script, and a shutdown script is important if you want an email after the process is finished. The previous example showed you an email being sent assuming that a feature was found during the process. Well, in this side of things, you might want to trigger an email after the process has completed, and if you want to do that, then you need to use a shutdown script. If I just dive over to this link here, if you search for startup and shutdown Python scripts in the FME documentation, you will get taken to this page, and there are a series of examples, and there's an example here for sending an email, and that's the one that I've used in my little workflow. So if I pop up the shutdown script process, I'm not going to run it because I've embedded a password and I've changed that so that you can't see it on screen. But if we just look in here, I'll show you where the Python script is. There's the shutdown Python script, and you can see that that's defined in there. The important thing is that you pass in things like the message, the account, and the password. That gets defined in this location. You could change the process so that it brings in a value that you are hiding, but the way that I've defined it, I'm just using the raw password, and it sends the message out to the individual target user. In this case, I've created a process that guarantees that it's going to fail, so I'm sending a null geometry to a raster mosaic, which expects a raster feature, which means that the process will fail, and as soon as it fails, it will run the Python script and it will attach the log file onto the email and send it to the person at the other end. So if you've kicked a process off on a Friday night and you want to know if over the weekend that it actually finished successfully, then this might be an example that is useful for you. Now, if we start looking at some of the web-based approaches around some of the capabilities around the FME server product, we can look at some of the examples that email gives us some benefits for. So, through self-service, you can provide emails in a number of ways. We're going to have a look at my instance of FME server. I'm going to log into it. I can go and run a job in here. So FME server gives me the ability to set up a data download service for individuals in or outside of my organization. If I go into the samples, you can see that I can go to this process that is registered with the data download service, and as an individual now I can log into this page and decide what data I want to extract from the organization's database, and I can do this through a web browser without necessarily knowing that FME is doing the work. So I can choose the layers that I want, the coordinate system that I want, and the format that I want, and I can define that, and I can then run the job, and that will, within the browser, give me a link to download the data. So we'll let that work, and I'll be able to get the link to download that file. If I set this process up to download the data using email, what will actually happen is, rather than me having to sit and wait for a long time for the job to be run and the browser to give me back the results, I can operate this so that actually what I'd get and manage my users' expectations is an email into which it contains the link to download the file. So that's going to pop up the answer for me, and I should be able to download the file. We'll let that just trundle on and get on with it. Perhaps could have chosen a process that ran a little bit quicker, but it doesn't matter. We have some time. Well, we'll let that get on with it, and it'll pop up in a moment. Whilst it runs, what I'm going to do is just run the same job asynchronously via email. And in this case, what I would do is send the same job, and this time I'm not going to be quite so ambitious. I'll pick an individual layer, airports, also to KML, and this time I'm going to email the results to FME on spatial at gmail.com. And rather than waiting for the process to run, this time I'll send it, and I get a notification that the data will be sent via email when it's done. Over in the other process, it's finished, and you can see that if I click it, I can download the file. Over here, at some point soon, an email will arrive, and there it is. It's been successful. And there's the link to download the file instead. And it's defined a little template that I've defined in FME Server to give me a template to make it look as if it's a professional data ordering system. Just a couple of other quick examples of ways that you can integrate with the Google platform, and these are a couple of nice little demos that are available in Safe Software's demo deck. Anybody can have a go with these. If you go and search on FME Knowledge Center for the spatial dashboard, you'll get an example that shows you a dashboard that's consuming live feeds of data, in this case bus data that is an XML feed, and plain data that is data coming from JSON, and that's being shown over the top of a Google map. And these are live vehicle locations that are moving around the map. It's going to be difficult perhaps for you to see too much of that over the screen. It should render reasonably well. You should be able to see each vehicle moving every now and again. I can zoom in on a particular area and see some bus activity down here, down in the bus station, and then some of the aeroplanes moving around a little bit. So this is an example that you can download. You can download the FME workspaces and all the details directly from either GitHub or just download as a zip file to take a look at. So if you want to get to these demos, the best place to go is to the FME Server developer playground. It's playground.fmeserver.com, and the demos are located in the top right hand corner. The other example that I want to briefly show you is taking a bit of vector data and rasterizing that onto a Google Map backdrop. Here you can see another one of those examples allows me to type in my email address, and once I've done that, I can define a boundary that I'd like to get some detail for. So I might be interested in the Rundberg Park. So this is a park boundary, and I want to make sure that the park boundary is rasterized onto the Google Map backdrop. If I send that request, what that should do now is send an email to me, and over here, and we'll hope that that arrives, and there it is. I now get a little Google Map as an attachment. If I click into it, you can see that I've got a clip of a Google Map backdrop, and it includes a polygon that is rasterized to represent the park extents. So it's effectively a way of ordering a small backdrop background to reference a bit of geometry that I may upload as part of the process, or perhaps use a drop-down mechanism like it is in this workflow here to define which geometry I want some background mapping for. So it's a nice little static map example. Again, if you download the workflow there, what you'll actually get is a workspace that shows you how it's done. The process itself, the key to the process is the transformer, the HTTP fetcher, which sends the request off to the Google Map API. And if I just pop that process up, you can see that in a little bit of detail if you're interested. So here's the request. So sending the request off to the Google server, the HTTP fetcher defined in here is sending a static map URL that you have defined in the workflow off to the URL, and it brings back, in this case, an image that you then rasterize the boundary in. So it's a neat little example you can download and work with yourself to see how that's done in a bit more detail. And then really just to conclude this session, I just wanted to highlight a last bit of technology that is KML but is a slightly different variation of KML. It's called a KML network link, and this is a KML file that contains no data, but it contains a link to go and generate some. In this case, I'm going to use the USGS site. There's a neat lot of sample data or live data that is being made available and published here at different intervals. So in this case I'm getting a JSON feed of earthquake hazards. If you take a look in here, you can see that there are different magnitudes of earthquake that are being published. So the one that I'm going to work with is the one for the past 30 days, magnitude over 2.5, and this is a JSON feed, 2.5 on the Richter scale. So there's the feed in its raw structure. Zoom in a little bit so you can see the detail of the text. But there's packets of data that reference the earthquake, its magnitude, and where it is. And what I'm going to do is use FME to consume that data. And what you might have noticed, if I just dive back, is that this updates on an interval of every 15 minutes. Some of the other ones are much more frequent. So what we would like to do is, rather than having to keep generating this KML file that we're going to work with, I've used FME server to generate me a KML network link. This service is automatically provided. This example is provided with FME server. So what we can do here is I'd use FME server to download the KML network link file, and I've done that already based on the workspace that I've adapted from SAFE's example. And I've taken, as you can see, a little KML link file. I know it's a link file because it's tiny, so it's got no data in it. If I pop that open in Google Earth, and I'm going to get rid of my balloon data while we're here, so I'll just delete that layer. And I'm going to just zoom out to the globe a little bit. All the way we go. And you'll see that this is a KML link file because in the navigator there's a little green ball, and if I turn that on, it goes and sends a request to FME server, and it runs a workspace, reads the JSON feed of the different earthquakes, and views that data directly on screen. Now at the moment, if I right click into here, I can go to the properties, and we have a little dialog box that appears that tells me a little bit about that feed, and it shows you the workspace and the connection to my FME server that I have defined, and the fact that that's running in a streaming service. And there's the workspace that's running. So it's the earthquake extrusion process, and it's running it with a whole bunch of parameters that are defined, but most importantly there is an interval. So if I set that interval to every 5 seconds rather than minutes, then that little ball there will every 5 seconds request the data, and you see that the screen will refresh any second now. There you go, it's done a refresh. And you'll see that the ball 5 seconds later starts pinging from side to side to go and re-request the data. Every time the screen refreshes, it's effectively run the job and got the data again. So what we would do is define the properties of this process and set that refresh interval perhaps to the same interval that the data is updated every 15 minutes. And now if we leave this open on screen, it will always show us the latest earthquakes globally every time that runs, without having to go and do anything else. And in this way, Google Earth is actually a client of FME server. Navigate around onto the horizon, you can see some of those up there. So let's just close a few of these windows. That's where I'd like to leave it today. I hope this session has been useful. We ran over time very slightly, but only by 4 minutes. Looking here at FME and the Google platform, a few resources to leave you with. There's obviously SAFE's website at safe.com. Please come and take a look at onespatial.com, and /FME will take you to some of our existing FME pages. /training will take you to our training pages, where you can see what training courses we have coming up and what type of training we can deliver for you. You can also go to our YouTube channel, where this session will be placed in the next few days, so check back there, and if you want to look at any of what we've discussed in this session in a bit more detail, or look at it again, then it'll be available for you to view on YouTube, One Spatial Group. Go and take a look at the Knowledge Center. This is the first and last place that you should look when you're looking for how-to capabilities. Do go and look at the Knowledge Center. There are lots and lots and lots of articles available for you to take a look at. You can involve yourself in the community answers site, so you can collaborate with other users, ask questions, or assist other users. Do take a look at the different blog. It's a very good way. Different blogs that are out there. Very good way of looking at very detailed articles on specific capabilities, a bit like what these webinars are focused to do. And go and have a look at the webinars site. safe.com/webinars will allow you to see what webinars are available, which is how some of you have subscribed to this webinar. We have a number coming up in the future, so already scheduled. Do join us again. Hopefully this has been useful enough for you to want to come back and interact with us on Twitter, and you can do that using @OneSpatial and Safe Software @SafeSoftware. But for now, I will take a look in the chat window, and if anybody's asked any questions, I will respond to those. But please hang on if you want to send a question over to us. But that's the end of it, this session. Feel free to get in touch with myself or directly with OneSpatial via FME@onespatial.com. But for now, thank you very much.